All right. JS's Weird Extreme Edition. Let's go. This is a big one. This is a big one. Marker. Okay, marker. JS is Weird Extreme.
Hello and welcome to Low Level JavaScript. Today we're going to be talking about the biggest reason that people...
Okay, this video does not start off on the best foot. Using this idea of low level and JavaScript in the same sentence just somehow feels... You know what I mean? You know what I mean? Like just right out the gate. Just right out the gate. When you allocate a string and you call substring, are those two separate strings or one string with a internal reference to just part of the other string? Can anybody answer me that question? If you can't answer that question confidently, then that's not low level. Okay, that is just as easy as it gets. Reference.
Say that JavaScript is weird, which is implicit type coercion. Now, at least once a year, there's a new wave of sort of JavaScript is weird posts that circle the internet, and they always use type coercion in some weird-looking way to produce an unexpected result, which produces the unusual string banana. Now, this is a toy example of how far this type coercion idea can actually be taken. And in today's episode, we're going to go to an extreme. Now, disclaimer, it goes without saying that you should absolutely not write code like this in a professional environment, but that doesn't mean that you shouldn't be able to understand it and explore it. So with all of that in mind, let's continue. So what if I told you that you can write completely valid JavaScript that can do anything, but only uses the following characters? Not only that, but we can easily write a compiler that takes regular JavaScript and turns it into this weird version in something like 45 lines of code or so.
I've always been curious about this, and I've wanted to try to write something with it. I've always wanted to do this. This is very exciting.
Well, that's exactly what we're going to do here today. So the basic idea here is really simple. JavaScript only has a few basic types, like strings, numbers, booleans, arrays, and objects, among some others. When you try to do things like adding two different types together, JavaScript uses some rules that it has at the core of the language to decide how it's going to coerce one of those types into the other type so that it can actually add them together. So if I try to add a string
Coercion? I hardly even know her.
To a number, the number is going to get coerced into a string. If I try and add a number to a boolean...
Welcome to Costco. I love you.
I love you too, baby.
Boolean is going to get coerced into a number. And we can see that we can take the number 2 and add it to the Boolean value true, which will give us the number 3, because true is coerced into the number 1, whereas false would be coerced into the number 0. So you can also use addition or subtraction with an expression to just cast one thing into a number. If we have just plus with an array, that's actually going to give us 0. This is called a unary expression because we only have one thing acting on by the plus. If we were to use a Boolean value instead, like plus true, we would see it turn into a 1. So we can kind of transform one kind of value into another. So the banana example that you see all over the internet, which is something a little bit more like...
Can we wind back up there? Did I just hear banana? Did we have a niner in there?
So we can kind of transform one kind of value into another. So the banana example that you see...
Yeah, he definitely tossed out a banana in there. That's full banana. I don't know about this banana. I don't see the yar in there. I don't know if I like that. I don't know if I like it.
All over the internet, which is something a little bit more like this.
British people, learn to speak English, okay? It sucks to invent something and also get it wrong, okay? It's always bad. Just like Netflix and the stars, 5 stars. We got that wrong. You just happen to get a whole language wrong.
We have the string b plus a, and then plus, and then a space plus, and then a plus a, and then we do a 2 lowercase on that. We should see this come out with the string banana, and that is because what we're trying to do here, the root of it, is that we're trying to take the character a and convert it into a number with a unary plus, which of course is going to result in not a number, because a is not a number and cannot be sensibly transformed into a number. And if you 2 lowercase that, you'll get the middle part of the string. And if we look at what it was before, you'll see that this is really this. So what we're actually doing is saying b plus a plus not a number plus a lowercase. It's actually fairly simple. This is the set of basic things that we're going to use in order to do something.
Don't tell Matt Podcock I said this, okay? Or Matt Pocock. Pocock. Don't tell Matt Pocock, okay? We're not going to talk about that, okay? Just don't tweet that. Don't tweet this moment. There's English, and then there are mistakes. This is true. Thank you for recognizing that.
Something way cooler. So first of all, let's figure out how we can get numbers. We've already seen that we can get number 0. So 0 then is just plus empty array. Now I'm going to store that away in a string so we can reference it later. So we need to get to the value plus true. But we can't use true because it's not in our list of valid characters. What we actually need to do is to get it somehow from our main type. So let's start with an empty array. And if we use the exclamation mark, we'll cast that to a Boolean. That will end up being the value false. But we can get it to be true by just using one more exclamation mark, which will force it to be true. And then we already know that if we just put a plus in front of this, we'll turn that into a number. And so now we have the number 1. Again, I'm going to wrap that up in a string. Now, how could we get any number? Well, pretty obviously, we could just sort of keep adding these to each other. So let's say we wanted 2. We could take this value and we could add another one of these. That would give us the number 2. And clearly, we could do this on into infinity. And so let's just write a general way of doing that. Let's write a function called number. It's going to take an n. And basically, all we're going to do is to create an array. We can do that with the array.from. We provide a length, which is n, because we want n elements. And then we can use the second argument to say that that should always be the number 1. And then we join them all together with a plus. Now we can return that. And so let's see if this works the way we expect it to. If we want the number 7, we should be able to say number 7. And we get this kind of expression. And if we take that out and we run that here in the debugger, we'll see the number 7. Perfect. So now we have a way to get any normal number turned into our strange sequence of characters. So now that we have these numbers, our goal is going to be to get the following letters.
That is most certainly how brainfuck was discovered, is that somebody discovered that you can actually write a subset of the JavaScript programming language like this. Okay, so
doing these strange operations. I'm going to write down here FROM, CHADET, capital S, ING, small c, UP, the character space, which I'll represent here with the square bracket.
From what word is that? From Cadet Sing Cup? What does that mean? I don't even know what's this function.
And we need a backslash. Now, why exactly do we need these characters, you might ask? Well, that's going to become clearer as we progress through the journey. But by the end, if we have these characters, we will be able to encode anything in JavaScript. So,
I know, I keep seeing Chad. I don't know how to... Chad has ruined me. When I see it, all I see is Chad. And I don't know how to spell it. God regrets free will after this. Chad at Sing Cup.
Let's get to it. The first thing I'm going to do is
I believe this actually was one of the Twitter users, or one of the Twitter devs that Elon was complaining about.
I'm going to write an object here. I'm going to call it map. We're going to store all the characters that we collect up in here. And the first one we're going to get is A. Now, we can get A by using the famous not a number example. So there's many ways you can get not a number. We can cast a letter to a number, but we don't have A in our disposal. But what we do have is an object. If we run this, then we'll see that we get not a number. But we actually need a string. And a good way, and the way we'll use for all of these things, to convert something which is not yet a string, but we want a string version of it, is to simply add an empty array. So in the JavaScript type coercion rules, that's going to force this thing to be a string. And we're going to be able to get the string, not a number. And strings have the property in JavaScript that you can index them like they're arrays. So we can provide an index and extract the character at that index. So if I wrap this up in parentheses and then we use square brackets, the second character in here, so the index number 1 is the letter A. So we can put in here the number 1 and we should see the letter A, but we can't use the number 1. We need to use our special number encoding. So we can actually just use number and 1. But this whole thing, we're going to store it as a string because we're going to want to look back at it later. So what I'm going to do is I'm going to put this in a template string and we can evaluate the number inside. And if we take a look at this, we'll see this strange little concoction and we'll just verify that we do indeed get the letter A. If we try to add an empty array to an object, it's going to force the object to be interpreted as a string. And an object, when interpreted as a string, always yields the same result. We take an empty object, we add an array, and we take a look. We're going to see the value object. But we can use this to our advantage because this contains quite a lot of the characters we need. For instance, it contains the character O, it contains E, C, T, the space. So let's just go about extracting these in exactly the same.
Even the person in the background was angry about this. Okay, if you can't use one, you should use a number. I like the idea that this is how I'm going to program JavaScript from here on out.
Same way we did before.
Okay, there we go.
Let's check all of those. And a nice shortcut we can use for this is eval, which will let us just run this as code, these strings. So if we have O, we have B, we have E, C, T, and space. All right. The booleans true and false are also a nice source of characters. We know we can get a boolean using exclamation mark, square brackets, and then we can add.
So you can't quite write anything. You're kind of restricted to the amount of strings you can create in the beginning. Is that fair?
Another empty array to cast that to a string. That's going to give us the string false. And from there, we can extract F in the 0th position. And we can extract S in the 3rd position. If we cast this to true, then we can get R in the 1st position. And we can get U in the 2nd position.
Okay.
Now, for the letters I and N, we can use the special floating point numerical value infinity. Infinity can be obtained in many ways, but one simple way is just to divide a non-zero number by 0. Let's take what we have here. We know we can get 1, and we know we can get 0 in this way. We should get infinity. And then if we add to this an empty array, we'll get the string. Okay, and here, actually, I've just realized there's a small mistake on the F, because we're providing 0 in here, and there's no way for us to get 0 from our current function. So what we should actually do is to add in a little condition here, which says if n is 0, then just return 0. Okay, so we've already gotten a good portion of what we need, but in order to get the rest of the characters, we're going to need to crank the crazy ratchet a little bit. If you're good at anagrams, you might have noticed that the letters we have so far can spell out some words. One such word is constructor. Now, all values in JavaScript are technically a kind of object, and you can always access properties on them with square bracket syntax. The following are quite valid in JavaScript. We can actually open up square brackets with a string and see the toString function simply by adding the string in here. Likewise, we can use the constructor function, which will provide us back the constructor. So how can we use this to our advantage? If we were to use this on a string, so we can make a simple string just by adding two empty arrays together, we would now actually be able to write this this word constructor out using our map. But it might be nice to have a sort of a more convenient way of doing that. So what I'm going to do is I'm going to write a function called fromString. FromString is going to take a variable s, which we're going to immediately split into an array of characters, and then we're going to map each character to be the value.
Oh my goodness. I never even thought about that. Oh, it's so right. Of course you could. Okay, so I went through this exercise a while ago where I tried to make the dumbest JavaScript program ever print out use Rust instead, but I couldn't figure out how to do it because I couldn't get all the letters. And look at that. I can't believe this. I can't even believe it. Let's keep on going.
Inside our map. And then we're going to join it all back together with pluses. And so this fromString, if we were to use it and provided the string constructor, and then run this piece of code, we're going to get quite an elaborate string. And I'm going to cut and paste this into the debugger so we can see it. What we actually get here is the string constructor. And if we take that one step further, and we take all of what we just got, we add an empty array to it, we'll have that as a string where we can extract the large capital S there. So let's try that.
I just held my breath. Oh gosh, I actually just held my breath.
Now there are a couple more constructors that we can abuse in the same way, namely the regex constructor. We can get that to get the letter P. And all we have to do is to create a minimal regex, something like this, and get the function constructor, and we should be able to...
I'm still holding my breath. Oh gosh.
Now, we have one more easy character that we can extract without too much hassle, which is the backslash. So we have to escape the backslash, of course. And the way we can get it is to just, again, create a regular expression, but we'll put a backslash in there. And in order for this to work, because of the way that string escaping works, we need to put two backslashes in there, because this whole thing is going to get encased in string. And we need there to be two backslashes when we evaluate it. So we create
I love the quadruple backslash.
Array in order to cast it to a string. And then we can look up the index, which is simply the number. Things are about to get tricky again, because the characters that we have left over now are not going to be found in this way. We're going to have to get them another way. The toString function of numbers is actually quite interesting, because it takes...
Okay, this is going to blow me. I already feel like I'm going to lose my shit when I see this. I am genuinely excited right now. This can't be real. It can't be real. This can't actually exist.
It's an extra argument, and that says which base the number, that string, should eventually be converted to. So if we were to have the number 170, let's say, and we were to convert that to a string, by default, that's going to be converted in base 10. So we're going to get the string 170. But if we were to provide a different base, say base 2, we're going to get the binary representation of that. If we were to use base 16, we would get the hexadecimal representation. And the nice thing is that bases which are larger than 10, they begin to use the alphabet in order to index the numbers. So we can use that to our advantage, since we can now actually make the string toString. We can get the letter D by saying that, well, D would be, in a number system, D would be the value 14, let's say in hexadecimal. Sorry, 13. D would be the value 13. But it would be the value 13 in any number system that let us get up to a character which would be D. So we can actually even say 14 here before we would get a weird result like this. So if we can encode this, which now we easily can, we can get the letter D.
Oh my goodness.
And it's quite interesting to see what this comes up with. This should just be the letter D. And this should be fromString rather than formString. But this kind of monstrosity is what is output by this. But if we run this, we should see the letter D pop out. Great. We can get the other three letters this way as well, or the other three lowercase letters at least.
Yeah, you can just get all the letters.
Now, to anyone that has used the language of the same name, it should come as no surprise that the letter C is going to pose some problems, and it's going to force us to do some really weird stuff. It requires some lateral thinking, and I'm actually going to leave a moment here to pause. Perhaps you might want to think about how you might make this work. Okay, if you didn't get it, don't worry, it's not obvious. We're going to need to access a constructor again, and let's build this up piece by piece. So we're going to need a constructor, but we're going to need the function constructor. So let's just evaluate.
I am really impressed right now. I just want you to know that. I don't even know what to do with this information, but I feel like I want to know more. I want to know. I want to know what's happening.
This in line so we can easily read it, and we'll take it away afterwards. We can get the function constructor by producing an empty arrow function. And then if we wrap that up, we use our from string with the constructor string. So when we've wrapped all of that up, we should see that we have access to the function constructor. But this time we don't want to cast it into a string. We actually want to call this constructor. We want to be able to use the function that this provides to us. And if you don't know what the function constructor actually does as a function, well, what it does is it takes a string that represents some JavaScript code, and it turns that into a function that can be called that will actually run the code inside. It's a lot like eval in that way, but in some ways it has a little bit more constraint which can be applied to it. Please don't take that as a testament to its safety. It's basically still like running untrusted code.
Oh my goodness,
but it's going to help us out here.
So
what we're going to be able to do with everything that we've put together from here is we're going to be able to use the string return escape. So what we're actually doing here is we're going to get a function that when we run it is going to return to us the built-in standard library function escape, which just like the name implies performs a string escaping to the ASCII value of certain symbols. If we call this function inline and I run this, hopefully we will see that we have here the function escape. And if we call escape and we pass that a string, then we should be able to see an escaped value. So what can we escape? Well, what we're going to escape is the map and then the backslash. Just the backslash. Let's run that and see what we get. We have an escaped backslash, which is the hexadecimal number 5C, and it's helpfully capitalized the C for us. So we can now take that whole expression and index it as a string, and we have our capital C. Actually, the game is pretty much over now. We've got our ultimate escape hatch. Now what we can do is we can scroll back up to the from string function, and before, if we had a key that was not in this map, then we were just going to get undefined, and that's no good. If we have a key that we haven't defined here, we should be able to find a way to produce that string. So we can say if x is not in map, then we want to get the character code of x, the numerical encoding of this character. And we want to get into the string constructor, and we know how to do that. We add two empty arrays together, we use from string, so we do a sort of recursive call here. And the string we want to get, of course, is the constructor. This is going to give us the string constructor, and on the string constructor, we have a static method. And that static method is called from charcode. And then to this, we can simply pass our character code, but we need to encode it in our strange number system. So this is our final output. And now we have a way to get every single character.
Why didn't you just do that to begin with? Right? Because I was wondering how he got that capital C, but you could just get capital C from the char code. I forget what capital C is in the char system, the system of chars. What do you think it is? Quick math. I'm going to go with 63. 63. Quick math. String from char code. 63. Oh, man, I was way off. That must mean we're really close. 5. There. Ugh, dang it. 67. 67! So stupid. So stupid. I didn't know. I thought it was 61 was the starting. Or 60 was the starting. I don't know what happened out there. Anyways.
Character that we cannot actually access through some other strange way by using our from char code. Let's actually see if this works the way it should. So I'm going to run here the from string function. I'm going to give it a character we definitely don't have, capital Z. That's going to give us an enormous, ridiculous set of characters. And let's run eval on that. And when we run eval on that, we can see the capital Z. So that's it. We're pretty much done. But we're not quite done, because the best we could do now is we could take some JavaScript code in and we could convert it into this strange set of symbols, but it would still only be a string. How do we get that code to run? Well, of course, we already know how to get code to run because we've already done it here for C. We need to just use the function constructor. So what we're going to do is we're going to write a function called compile. That's going to take some code. And all we're going to do with that is return a string, which will be the function constructor. We know how to get that. And then we need to call from string, just the code. And then this is just now a function, but we need to run that function. So we just immediately call
Come
it.
on! I can't believe I didn't see the X. What a rookie! Didn't even see the X.
The result of calling compile.
Look at that. Everyone's laughing at him, not even seeing the X. He doesn't even know about it.
On a string, and in the string, let's actually do a console.log. Let's say hello world. So this is the world's most ridiculous hello world program, and it will of course help to not have the letter X there instead of the letter C, which this should be. Let's change to the terminal. Let's bring this terminal to the bottom, and let's run this crazy program. It's like looking at some sort of weird matrix. Let's pipe that into a file called output.js, and if we open that up and take a look at it, my syntax highlighter is going to struggle to try and parse this file. Oh my gosh! So it goes on for pages and pages, and there's no sense in there. But hopefully, if we run this, we actually see our message hello world. So now, the next time someone shows you a toy example of the banana that's blowing their mind, I hope you point them to this video and show them what can really be done if you mess with type coercion. Big shout out to Martin Klepper, who was the guy who figured all of this out a few years ago. I'm going to put a link below to his website, also the GitHub repository where I'm going to put the code of today's video. I hope you've enjoyed this low-level JavaScript.
Oh. What the hell is even that? Well, what the f? I don't even know what to do with this information. Honestly, I don't even know what to do with this. I don't even know what to do with this. Other than I want to somehow use at least 0 or 1 in production. I don't even know what to do here. All I know is I'm so happy. I feel so weird right now. Yeah, yes, I've seen this. I've seen this. I've heard about this. Right, so you can encode this beautiful thing and bam, and then just look at that. It just works. It just works. It's so beautiful. I don't even know what to do with I don't even know what to do with this information other than what the f? How does someone... Okay, so just can we all take a second here? There was somebody's life that spent likely days trying to make this work out. Now, I would like to make fun of the guy, but truly, I can't. Because I am that guy. I am that guy. Maybe it was an accident. You don't make a compiler on accident, okay? You know how many stupid things I've made just because I felt like I could? I don't know. It just feels right. You know, like in the moment, it feels like you just need to do that. This is one of those times.